Hello everyone, welcome to my presentation, and I'm sending my greetings to the organizing committee for organizing such a nice conference like this. By the way, as an author, I am responsible to give a presentation here. So without further ado, let's get started. Well, as you can see on the screen, our presentation title is Automatic Bone Mineral Density Estimation from Digital X-ray Images. Authors Abdullah Al-Mahmoud and Colin Kumar Halder. Presented by me, Abdullah Al-Mahmoud, IICT, Kuwait, Bangladesh. Contents of presentation. Some key points are written down here, so let's read them out. Introduction, problem statement, related works, research questions, objectives, methodology, results and discussion, conclusion. Introduction. Well, through this research or through this paper, actually bone diseases are diagnosed. And bone are the most significant moving parts of our body. And osteoporosis is a kind of disease that occurs in bone. And osteoporosis mainly affects in human bones like femur region, hip region, knees and spine, etc., etc. BMD, that means bone mineral density test, is a gold standard for diagnosing osteoporosis. And what imaging technique we're gonna use to solve this approach? Definitely digital X-ray imaging technique would be used to solve this problem. Problem statements. BMD is conventionally measured through two schemes called DEXA or DXA. But this scheme is more costly and time consuming as well. So need to find a best solution out of it. Anyway, using digital X-ray images to estimate the BMD solve this issue. Why? Because this is much cheaper than DEXA or DXA. Anisotrophic diffusion filter. In our concern, we have used anisotrophic diffusion filter. Why? Because other filters are performing lesser than anisotrophic filter. Related works. Well, there are a number of authors who have already discussed their ideas regarding these concerns. So I'm not gonna read out this sentence, rather I would explain the figures. As you can see on the screen, the DEXA scan and MATLAB code both are producing a result which is osteoporosis and osteoporosis. In terms of number one, the region is proximal femur and the age is 85. Both the DEXA and MATLAB code producing the same result like osteoporosis and osteoporosis, and the BMD scores are given here. Well, the osteoporosis occur or bone mass decreases when bone mineral calcium is become lesser. The author Jayan et al. Explained that DEXA and DXA scanning for BMD estimation is one of the existing methods. By the way, another key note is that DEXA is most often performed on lower spine and hips. Artificial neural network is another way that has been used to detect osteoporosis, and the author Leminer et al. Explained this model. The CT scanning, that means computed tomography, is another way of detecting osteoporosis. Age and gender is very crucial term for detecting osteoporosis, and postmenopausal woman has lesser BMD score. If we consider the below figure, it is shown that women have less bone mass than men and young people. Research questions. The primary research question is to achieve more accuracy and quick diagnosis of bone disease. The brief discussion would be covered up in upcoming slides. Objectives. Well, let's read it out. The points: early detection of bone fracture risk, BMD estimation through bone thickness T and diameter D, using digital X-ray images instead of conventional DEXA or DXA scanning, reducing the execution time and cost compared to other existing methods. These are our objectives. Methodology. Our proposed methodology consists of two strategies like pre-processing and post-processing. Anyway, we have segmented this methodology into several images for having a clear brief. Into the pre-processing, what we are doing, we are taking an input image that must be an X-ray image. After that, we are resizing that image for our convenience. Once we get the resized image, it is converted to grayscale image, and we are finding the ROI, that means the region of interest, from the ROI segmentation. And then we are applying the noise reduction schemes using several filters. But we experimented several filters, but in our terms, we observed that anisotropic filter, that means anisotrophic diffusion filter, performing far better than other filtering techniques. Post-processing. We have segmented this post-processing into two schemes like VPA calculation and BMD measurement. In the VPA calculation, what we are doing, we are creating a profile graph using imProfile function, that is MATLAB built-in function that produces an intensity profile graph, and we measure the thickness T and diameter D through that profile graph. After that, we calculate the VPA, that means volume per area. BMD measurement. The VPA is multiplied by specific density called rho to get the BMD value, and once we get the VMD value, we can calculate the BMD score, and upon the BMD score, we can take a decision whether the bone has osteoporosis or osteopenia, or it is a normal bone. Results and discussion. Well, this is nothing, just an digital X-ray image. Post-processing, what we have done, we have resized the image, we have converted the grayscale image, we have segmented that image to find the ROI, and then we have done the filtering approach to get it into the next phase. Post-processing results. After using the imProfile function, that is MATLAB built-in function, we are generating this curve, this intensity profile graph. Well, the results and discussion table. After observing the results, it is stated that our proposed method performing far better than existing methods. Like we are getting a more accurate results than the compared one. Conclusion. What we are proposing through this study or through this paper or research, actually we are proposing an automated scheme by which the bone diagnosis can be done, or the early detection of bone disease can be done, but definitely through using digital X-ray images. And this is really a very cost and time effective approach. By the way, the experiment uses only femur images. Other regions like spine, hips, etc. can be done, but take a note that the specific density value would be changed. End of this presentation. If you have any questions, please feel free to ask me. Thank you for your attention.